There's quite a bit of time between these videos, that's why it's kind of a hodgepodge. Hello, this is Jim. I am going to be building a bifold door for my shed. It's behind me. Got some challenges. It's got a sloping roof. The bifold door is a hangar door, goes like this, and try to work you through it, how I design it and put it up. The things to worry about are the opening, how tall it is, how wide it is, what the structure is behind it. In this case I've got steel beams instead of wood, so I should be nice and strong. The hinges at the top are going to be up near the roof line as much as I can in a straight line. It won't follow the angle there. And then the bottom door will ride along these posts on the inside. I'm going to try to find some, I haven't found them yet, some bits of channel where the bottom edge of the door will ride up along. And then when it goes out, I'll have to figure out what the angle would be to give me I found a good term on YouTube called wedge. How much of a wedge the door will create when it's open. See how we go. Okay, first thing to make are these hinges. It's going to be at the top and bottom of the door. And these are some hinges that I had for about 16 years. I've been saving them for something. So there's some used hinges. I've got to, since it's a corrugated iron wall, I've got to make sure that they have spacing right. So I'm going to make a pair of hinges. This is the original door. I've made two now. This is the original, made of wood. There are some other differences. I'll try to show you what they are now. If you've seen the other videos, I'll reference those in the text. You can see how this original one works. But I'll just show you some of the differences. This is kind of awkward. I'm going to shake the camera around a bit. I have these latches. Swing that back, push that up. Well, I got to pull it in a bit because there's a lot of friction. Holds it in nice and secure. It holds it from going in and out. I can't pull it in and I can't push it out. The little latch keeps it from people can trip it from the outside. Can't happen. Now the door is pretty much opening itself. It's got this counterweight right there. And if I pull the door up, I'm just very light touch pushing the door up. Kind of where it goes down. And something that's common to both doors is this track I've got, and that just keeps the, that's lead, 37 kilograms of lead, and a paint can. And that keeps it from spinning because those two cables tends to spin and it binds up. Two cables, counterweight cables, pulleys from your hardware store. One of the main differences is this is a roller bearing that is riding on the outside of this beam. It's basically a steel beam on the inside. And that's the same. That's a gate hinge. It's the same to the other door. A gate hinge, it just holds the counterweight strap. Hinges on the outside because it's wood, corrugated iron. These are just door hinges you get at your hardware store. Those little brackets there are the outside of what supports the top panel to the upper hinge. Pull this down. You can see the gate hinge I've got up there, corrugated iron, and the straps that hold the upper part of the door. This is all, those parts are in common. You can also see there's a bit of a slope on the roof. The hinges are level, but the roof slopes, so it looks like that. Okay, I'll go inside and show you the other door. Straight through. It's kind of a funny shed. I can go in and out. I'll set this little camera up on this handy table saw. See how that works. Now this one's made of metal. This is 1 inch by, well, I'm in South Australia, so this is 25 millimeter by 40 millimeter rectangular tubing that you use for fencing. These are lighter gauge hinges. They're screwed on instead of, well, they're still screwed in, but the bottom ones are welded. It was more secure. I've used a bit of wood here because I needed something, it worked better for me to use wood here. Basically the structure is still steel. The top and bottom panel is framed in steel. The bottom panel is steel. This is steel, but I've got a bit of wood here and a bit of wood at the bottom for a gap fill. The latch is different. Move it up. There's a pin that goes on both sides. Push this one out. The exposure's gone off because it's so bright outside. Sorry about that. And here's some of the differences though. Still got the counterweight. Still got the two pulleys up there. The track that keeps it from spinning, and the counterweight, which still weighs around 35 or 34 kilograms. The door itself is a bit lighter. But the hinges, or the, not hinges, these are the tracks on the back. That's inset. It goes up even, up on the inside. It gives me another 3 inches clearance. The door is also thinner, so I'll also get more headroom on the bottom of the door when it's open. Here's the main difference, is this track. This is the standard garage door track that you'd get on any kind of door you might have in the States, or not so common here in Australia. But it's got a wheel that rides in there, and it's just terminated at the top, so I don't have to go any further than that. Got these gate hinges to hold the counterweight straps, same kind of pulleys. And on the outside, still got the same kind of gate hinges up at the top. And again, the slope of the roof, and the hinges are still, there's a steel beam on the inside that they're bolted to. Keeps it nice and strong. You see the bottom bracket holding the bottom of the top panel. And there's another bracket up the top holding the top of the upper panel. This is easy. I just move this handle and slides the pins in. Here's the tracks and the wheels that ride in the tracks. The tracks end at the top. Here's the latch. When I pull this, retracts those. I can give it a push. The counterweight's over there going up and down. Go on the outside. You see the seam running across the middle? When it comes open, it comes out. This is coming out a bit. Here's the metal structure of it. I'm just doing that by itself. And the wheels right on the inside. I've got this rope hanging here because my wife is shorter than me, so she needs a rope to pull it shut. This stands off about 4 inches, well, 3.5 inches from the outside of the door. It's one measurement. From the inside of the door, it's quite another one. And the critical measurements on this door is, this is one pivot point. The hinges are the other pivot point, or a second pivot point. The third pivot point is up there. I don't know if that camera's pointing in the right way or not. At the top, that's the third pivot point, which is on the outside, and that caused some trouble. I've got one pivot point on the outside, top. The bottom pivot point is on the bottom, inside, and then the hinges are somewhere in between. It's not on the inside of the door, it's not on the outside of the, well, it's on the inside of the door, but it's not way out here. It's inset. So all that made it kind of tough to get the measurements right so that it would create the wedge. A wedge, try to aim for to be self-supporting and not fall down or poke up. That's your wedge. It's a nice triangle, self-supporting triangle.
the middle, that middle pivot point there, that's got to be, you know, when that's finished, I had some complications there because that's really close to that beam, but the wedge can't be pointing up and it can't be pointing down. It's got to be in the middle. So all that's got to be part of your calculation. This video's gone on a bit. Hope you all enjoy it.